This is 7.5, algebraically defined vectors and the dot product. In the previous lessons, we drew diagrams on a blank page. We represented vectors anywhere we wanted, and they were labeled with simply miles per hour or newtons, representing speed or force. In this lecture, our vectors are going to exist in the xy plane, meaning that their beginning and ending points will have distinct coordinates. The magnitude of a vector is simply the length of the vector. So what you see down here, this formula for magnitude of the vector, is nothing other than the distance formula. So whether you use the distance formula or you use the Pythagorean theorem, ultimately the magnitude of the vector is still just the length of the vector. So now I want to go to homework 21 from MyOpenMath and look at problems number 1 and 2. Okay, so in problem number 1, we're supposed to find the magnitude and the angle of the vector shown above. So let's look more closely at that vector. So the magnitude of the vector is simply the length of the vector. And you can see that you have a right triangle that is formed by the grid of the xy plane. So if you were to take that right triangle and draw it out, then you see that you have a side length of 1, and then you have another side length of 4. So using the Pythagorean theorem, we can find that the other side length is the square root of 17. So the magnitude of this vector is simply the square root of 17. So again, you can use the distance formula or you can use the Pythagorean theorem. I don't need to see any work for how you come up with the magnitude. The magnitude is really not that interesting of a problem. What's more interesting is the direction. So what you need to do first is figure out what the angle is inside of your right triangle. So if you let this angle right here be theta, and you want to pick the angle that is attached to the origin, okay? So pick the angle of the triangle that's attached to the origin. Then to find out theta, you would say that the tangent of theta is equal to opposite over adjacent. And then just make sure that you are in degrees and not radians. So then if theta is 14.04, and you can get that using tan inverse on the calculator, then the supplement of that angle would be the remainder of this line here. And so the supplement is 165.96. And that would then be your direction angle for your vector, starting at the positive x-axis. Now there is another way of doing this problem that some people find a little faster. It's a little more dependent on a formula and less dependent on your intuition from geometry. I'm more of an intuition person, so I like to just go back to what I know from geometry. But if you like to have a formula instead, then on page 336 of your textbook, you will find in a green box the magnitude and the direction angle of a vector a comma b. Now let me point out some notation here. Now the book doesn't use this little half arrowhead line on top of the letter U. They use the bold letter U. But because we're handwriting it, we're using this little half arrow line segment. This right here is the way that we represent the components of a vector. We use actual sideways looking V's instead of parentheses. So those are actually jagged like a V on purpose. Those are the components. Then here's the formula. This is akin to the Pythagorean theorem for the magnitude. And then for the direction angle, you can simply use B over A. So looking back here at our graph, how would we write the components of this vector? Well, this vector has the components -4, comma 1. And notice again, I'm using those sideways v's instead of parentheses. So those are the components of the vector. And then you can use the tan theta is equal to negative 1 over 4, or rather 1 over negative 4 according to this formula. Now, you've got to be careful that when you type in tan inverse into your calculator in this way, you're going to end up with theta is equal to negative 14.04. And thinking about the fact that our vector is in the second quadrant, we know that this is not an acceptable answer. So what we need to do is we need to add 180 degrees onto this value so that we can end up going from down here in the fourth quadrant up here to the second quadrant. And then when you add negative 14.04 and 180, you do get your result right here that we had already said was the answer, 165.96 degrees. So when you get to question number 2, you have some options for videos here. I just wanted to point out again that sometimes vectors are written with a half arrowhead and sometimes they're written with a full arrowhead. The components again are represented with these sideways v's instead of parentheses. And in this particular problem, we're not dealing with degrees, we are dealing with 0 to 2 pi, so we're in radians, but we're still measuring from the positive x-axis. We're still going counterclockwise from the positive x-axis. Another thing you'll notice here is that the magnitude in this case is represented by 2 bars. So there are multiple notations. There are multiple different notations that mean the same thing. So the book is going to use a single absolute value bar on either side for magnitude, and this particular problem is using 2 bars. But when you take the square root of 4, when you square the 4 and you square the 6, you get 16 plus 36, which is the square root of 52. Now, of course, the square root of 52, you can get that decimal approximation that the MyOpenMath is looking for when they grade your work, but what you need to be typing in is not the decimal approximation. You need to type in the reduced, simplified answer here. So since 52 is divisible by 4, then square root of 52 simplifies to 2 root 13. So that's actually the answer that you want to type in. Yes, if you type in 2 root 13 to your calculator, you will get this as a decimal approximation, but what I want to see from you in this problem is the exact magnitude, not a decimal approximation. Okay, now for theta, remember 4 negative 6 is going to be in the fourth quadrant. So when you go down to the fourth quadrant, just make sure that your theta value is in the fourth quadrant. Make sure that you're going counterclockwise. You'll go all the way around, and you should end up with a positive answer. Your answer needs to be between 0 and 2 pi. So if you take tan inverse is going to give you that theta is approximately negative 0.9828 if I use my calculator. Well, I know that's not between 0 and 2 pi, but this is the result that I get using inverse tangent on the calculator. So what I need to do is find an angle that's coterminal with this angle. Yes, this angle is in the fourth quadrant, but no, it's not between 0 and 2 pi. So I just need to add 2 pi, and when I add 2 pi onto that value, I end up with the correct answer right here. So that's how you make sure that your answer is correct for that problem.